Hello friends, welcome to SahuStudies. In this video, we are going to see what is the difference between reduce by key and combine by key in Scala. So let's discuss about what is reduce by key. So reduce by key is a transformation function and it is a wider transformation. So this reduce by key will going to help if you want to perform any kind of a transformation, and this is a wider transformation. So whenever the transformation is wider, then the shuffling of the data across different executor over the network happens. It uses merge the value key each key. It uses associative reduce function on the PySpark RDD to merge the value of the each key. So let's understand this point. Okay. So what reduce by key generally does, it merges the value of the each key, right? And it uses the associative reduction function on the PySpark RDD to merge the value of each key. This is a wider transformation, hence the shuffles of the data across different partitions will going to take place, and it operates on the pair RDD. So wider transformation, shuffling of data will going to happen across different partition, but the best part is that the shuffling of the data across different partition happens at the last stage of the transformation, and reduce by key operates on the pair RDD, in which values are present in the form of key, data is present in the form of key and value. So it is very useful when there is a requirement to perform aggregate function on the values which are associative, which are associated with key. So suppose if we want to calculate sum, or we want to just figure it out, what is the minimum value, what is the maximum value, which are associated at a per key label. Associated with per key label, which is very important to understand. So with the help of a reduce by key, we able to figure it out those. One of the main advantage of reduce by key is that it reduces the amount of the data that's need to be shuffled and stored, and that is able to store in the memory. So let's understand this point in detail, right? So what is the advantage of the reduce by key? The reduce by key is very fast. Why it is very fast? Because the shuffling of the data across the different executor over the network become very fast. Why? How it is possible? So whenever we are applying the reduce by key function to do certain kind of aggregation, so aggregation is happening first at the local level. Local level means per partition level, uh, uh, aggregate function is running. So suppose there is a sum aggregation in one partition, there are 1,000 records are there, but when the aggregate function is applied with the help of a reduce by key over a, and what the reduce by key will going to do, it will going to merge the value key level. Okay, so after the merging in one partition, what is the total amount of data it would be? So suppose there are 4 unique keys are present. So only 4 data points it will going to create with what is the value it would be. So suppose in the raw partition 100 MB data are there, and in the result of the aggregation on that particular partition, the data could be 1 MB. So hence when the data will be reduced drastically with the help of a reduction function, then data will going to sit on the, or you can say sit in the memory well, and when the shuffling will going to happen due to the small size of the data, the shuffling will become very fast. One of the main disadvantage of reduce by key is that it requires the reduction function that is associative and cumulative, which may not the case of all the aggregation function. Suppose we are going to use mean, max, sum, count. Those are associative and cumulative functions, which is very much as achieved if you want to perform over a sets of data with the help of a reduced by key. But suppose if you want to aggregation like a standard deviation or mean or median or mode, those are not associative or cumulative. So those types of aggregation will not be going to happen, or we are not able to figure it out with the help of a reduced by key. Let's understand the reduced by key with the help of this pictorial representation, right? So this is a one partition, this is another partition, this is the third partition. These three partitions sits in the different executor. So suppose we are doing this sum aggregation, right? So sum aggregation is applying in each partition. That's why this is the result of the sum aggregation. This is the result of sum aggregation, and this is the result of sum aggregation. So it has happened locally. Locally means for each partition, this sum aggregation function is applied. Once the reduction function applied over each and every partition, then the shuffling of the data is going to happen. So what it will going to do, the data will going to bring from this partition, from this partition, from this partition in these two partitions, and these two partitions are created based on the key. So suppose this partition has the key A, this partition has the key B. So let's see from where the data is coming. This data is coming from this one. This is the result of aggregation function which is applied in this partition A2. So this is the result of the data which gets output once the aggregation function applied on this partition. This A3 comes from this partition. This is the result of aggregated function which has been applied over this partition. Same for B, like this one and this one. And once the data comes in this partition, again the aggregation function is going to apply it for this partition, and again the aggregated function is applied over this partition. So sum is there. So here the aggregated value is like this. A is equal to 6 because here the value is 1, here the value is 2, here the value 3. That's why A is equal to 6. Same for B is equal to 6. So in the reduced by key, first the aggregation function applied locally on each and every partition, and when the partition, each and every partition, the aggregated result comes, then the shuffle operation going to happen, and the data will going to move across different partition based on the key. And when the data move to the partition, again the aggregation function applied. So here the aggregation function is sum. So it is applied here also, here, and it has been applied here also. Let's discuss about combined by key function, right? So combined by key function is a transformation function, and it performs transformation operation on the pair identity. So whenever we want to perform combined by key function, no, so the input data must be a pair identity, and the data must be in the key and value pair. So it also requires shuffles because it's a wider transformation, but the good thing is that it requires the shuffle at the last stage. It's a very generic function to combine the element of each key with a custom aggregated function. So suppose we want to write a custom aggregated function, custom aggregation, and want to apply over a RDD, which is a pair RDD on which data sits in the key and value pair. And if you want to do custom aggregation on the per key label, then with the help of a combine by key, we can able to do it. One of the main objectives of combined by key transformation is that it takes pair RDD, key and value as an input. It also returns the pair IDD, but the data type would be different, right? This C is the result of any type of aggregation. So which type of aggregation we are performing with the help of a combined by key, no? So this C is the resultant of that aggregation type. If there is a requirement to perform custom aggregation on the value of pair RDD while providing fine-grained control over the aggregation process. This is the same thing, right? Whenever you want to do any kind of a custom aggregation on top of the RDD, where the data sits in the key and value pair, and if you want to perform custom aggregation on the values for each and every key, then with the help of a combined by key, we can able to achieve it. And whenever we are just calling the combine by key function, so it takes three parameters. And three parameters, one is the initial value. What is the initial value? The initial value is 0 most of the time, and it is used to initialize the accumulator. Once the aggregation function going to apply on each and every partition. This combination function is the combination function for value within the partition. So this combination function, what it will going to do? It will do the aggregation on the value which is present in the each partition. And this merge function, what it is doing, it's combining the result across the different partition. So whatever the result it would going to create it with the help of this function. This third function will going to collect all the result from the different partition and merge it and give as a output, as a result. Let's see how combine by key function works. So the way reduce by key works, the same way combine by key going to work. It first do the aggregation at locally. So here the aggregation it is doing locally. So same pictorial representation I have explained in the reduce by key. Same thing is here. First the aggregation is going to happen in this each partition label. Shuffling of the data is happened. Then here it is again the aggregation function is applying. So here the first aggregation. So here first the 0 it is initializes with the 0 value. The first point which we have seen here, no, this one. So for the each key it is initializes with 0, means accumulator is initializes with the 0 value. And now the second one is combining functions value for within the partition. So here what it is doing, it is combining the value of each partition in each. So each key, what is, sorry, let understand this better. Okay, so here what is doing, the second function is combining the value of each key in each partition, combining the value of each key in this partition, combining the value of each key in this partition. And the third, what is doing, merging the function to combining result across the different partition. So here what is doing, it is merging the result which is the output of combination. So here this is the output, 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 this is the output. Here the shuffling is happening, and this output A comes in this partition which sits in the different executor. Here is the B which sits in this partition which is coming from, which is the result of this aggregated function which has been applied over each and every partition. And once the data is coming in this partition, again the aggregation function is applied over here. So what is the difference? So let's discuss about the difference. So reduce by key is more suitable for cumulative and associative reduction function of the value. So suppose we want to do any kind of aggregation over the value. Okay, so if the aggregation is cumulative and associative like max, mean, count, sum, then the reduce by key will perform better. It performs the logical operation in the each partition before shuffling. As I told you here the reduce by key, first the aggregation function is applied on the key on the partition level. Each partition level. It requires less memory. Why it requires less memory? If the aggregation is happening local level, the data is reduced drastically, and when the shuffle operation going to happen, then the data will able to sit in the memory which is available, and the shuffling becomes very fast. It has limited flexibility because it has fixed reduction function. So if you want to do any kind of custom reduction function, no, it would be very difficult to do with the help of a reduce by key. It provides better performance due to the local aggregation which we have understand it. What is the logic behind doing local aggregation and how the data is going to reduce drastically whenever we are using the local aggregation. Let's talk about the combine by key. Okay, it allows more flexibility for the custom aggregation logic. So if you want to write a custom aggregation logic, then with the help of a combine by key, you can able to do it. It allows a specific function for creating the initial value, and merging value across partition. So as I told you that whenever we are using the combine by key, then there are three functions and you can write these three functions custom, right? So you want to do any kind of aggregation you want to do, so these three functions you can write in own way and you can use with the help of a combine by key function over a pair RDD. It offers more control over the memory usage and performance dealing with the appropriate aggregation function. As I told you, like uh, when when the reduction function is applied over each partition, the data will become very less and it will be very performance optimized whenever it going to shuffle the data across different partition over the network. It requires more effort in implementation. As I told you, there are three functions generally we write whenever we are going to use the combine by key function. Then we have to give more effort to write those three functions. That's why I have just written here that it required more effort in transformation. So these are the some points or some different points. If you just thought or I have just figured it out. So I have just created this video, and now if you just reach to that point at this point in this video, then you can able to figure it out what is the difference between reduce by key and combine by key in Scala. Thank you. If you like content of my video, then please subscribe my channel, like it, comment on it, and press the bell icon to get notification whenever I add videos.